Welcome to another episode of Inside Platform Engineering. I'm joined here today by Peter, and I'm really excited by this discussion because we've had a few chats already, and I know you've got a lot of experience, a lot of ideas, and a lot of opinions as well. Peter, did you want to let folks know who you are and what you do?
Yeah, so my name is Piotr Szwed. I am a kind of solo consultant at the moment, working in infrastructure automation field for almost 25 years already. So my main focus is automation itself, not particular tool, not particular framework or technology. I always try to focus, on the generic, model of how can we automate the infrastructure in a better, more efficient, more optimal way, right? So that's more or less my passion, and this is what I like to do.
Awesome, yeah. And I've been asking folks on this series to just baseline what they think when someone asks them what is a platform and what is platform engineering, because there's a lot of different opinions out there depending on who you're working with and what you're doing day to day. So I'd like to get your take on what a platform is and what platform engineering means.
Yeah, I think this is a very difficult question, and we are in a kind of similar situation to DevOps, actually, right? Because
Hmm.
I remember times when everyone was asking actually what DevOps is, and every organization, every team was having slightly different understanding and slightly different answer to how they actually understand DevOps and how they implement DevOps practices. And I think same issue applies to platform engineering today. For me, so yeah, as many people as many good answers out there, right? But for me personally, platform engineering is like the next iteration, the next refactoring, or the next generation of tools of methods, allowing us to automate infrastructure. But this time, API oriented, 100% API oriented. In 2026, there is no room for any tools, any frameworks, and technologies and patterns which are not API oriented, right? We are living in a kind of AI agents era today. Agents need some sort of APIs, interfaces to talk with, right? So if you want to enable AI, not only for the software itself, but also on the infrastructure layer, we need to build infrastructures. We need to build organize our processes in a way which is 100% compatible with the agentic environments, AI in general. And the only way to do so, I believe, is API first approach, which is relatively simple and obvious, but when it comes to details, the tools we use for infrastructure management, the frameworks we use, the patterns, the architectures we follow today, it's getting actually quite complicated because there is still a lot of tools, a lot of frameworks on the market which don't have proper APIs, which are still managed like 5, 10, 15 years ago, and are not, I would say, ready for the proper AI integration.
Hmm.
So for me personally, platform engineering is like the new way of building infrastructures, allowing us to enable all the features, all the power coming with AI. That means that we need to, and yeah, I need to say this finally, but we need to forget about the tools like Ansible, Puppet, Chef, Terraform, OpenTofu, all the tools which were built in the in the years where there was no AI, right? Where humans were the main users. And what is also very important here is that in my eyes, Terraform, OpenTofu, these kind of tools were created to automate humans' work, right? Our day-to-day work, everything what we do, with our infrastructures on a daily basis. But the future belongs to autonomous infrastructures. And this is where Kubernetes is, in most cases, acts as a kind of default choice.
Mm-hmm.
So most of the autonomous systems, which can self-heal, which can autoscale, which can perform rolling upgrades with no downtimes for the end users, right? So, to summarize, first of all, the infrastructure where AI is a native citizen, which I call more and more often AI native platform engineering today, and infrastructure which is designed to operate as autonomous systems, with much less focus on so-called automation, right? Automating our day-to-day work. This is not needed. I believe that we don't need to automate our SRE or DevOps people or platform engineering teams work anymore. We need to build autonomous systems, and this is a very big difference in the way of approaching the infrastructures today. But of course, for every organization, it may mean something different. There's no book or Bible or manifest, explicitly saying what platform engineering is. For me, this is about these two major concepts: enabling AI agents so they can talk to the platform engineering interfaces, and building fully autonomous systems.
Yeah, that's very interesting. And yeah, you said quite a few things in there, which we'll have to unpack. And one of the things that you mentioned in there was along the lines of this hasn't been the standard approach for many people to think in the way that you just said. Like, it's to use tools that we've known about for quite a lot of years, and start building like a platform on top of those tools, and then have ways to automate the running of those tools, maybe for the developers if they need a new environment or if they need to make a change. So it sounds like this is the approach that you're saying here is a pretty big mindset shift. Is that fair to say that most people have had when it comes to building these platforms, and maybe being able to take a step back and think about where we're at today, what's happening in our world right now, and how can you build a platform that's going to account and adopt future technologies?
Yes and no. I would say there are no simple answers there, but what is good about the future infrastructures is that in my eyes it is much easier actually to manage, much easier to build, much easier to manage than all the old-fashioned technologies that we know from the past, right? No one uses Perl scripting anymore, right? For a reason. It was extremely complicated. It was very hard to manage. Automation frameworks built on top of Perl. I remember these days, it was like 15, 20 years ago, right? All the future ways of managing the infrastructures, which we put under the platform engineering umbrella today, in my eyes, are much easier to what we know from the past, right? Even Terraform or OpenTofu scripting, I think, is not as easy as future YAML, which we are going to use in Kubernetes or Kubernetes operators ecosystem and so on, right? So I think that from this point of view, what is coming is easier, is very easy to learn. So if you already know OpenTofu, if you already know Ansible, if you know Chef, Puppet, and this kind of tools, it will be very easy to switch to the Kubernetes operators model, or maybe some agentic infrastructures frameworks which are going to pop up this year. I'm pretty sure about that. So this path is going to be easier. But what you said is very important, because there's lots of teams, there's lots of people, doing the same work for 2, 3, 5, 7, even 15 or 20 years. With use of the same practices, the same models, the same tools. And this is really not that easy for everyone actually to adapt to the change, right? Even changing from HCL, Terraform, DSL, domain-specific language to YAML is a kind of scary move, and for many people it's a big problem. Yeah. Especially when dealing with very complicated infrastructures with lots of different dependencies, enterprise scale, lots of different teams involved, networking, security, databases, developers, everyone having different requirements, all these political issues, political games, and so on, right? So in practice, it might be a little bit complicated. But this is also where we can, learn from the others. This is also why we have this kind of, podcasts, webinars, conferences, meetups. I think this is going to be a key factor in contributing to the change, to the mindset change over the next years. So we need to learn from the people who already managed to migrate from A to B, right? Learn, all the best practices from them. Learn, how to start, how to perform the migration, how to perform the transformation. There's lots of vendors supporting the journey, and I believe Octopus Deploy is going to be one of them. You have quite a lot of tools in the area, right? So there is lots of vendors supporting the journey. I think this is just the beginning. I just noticed a couple of US startups getting another investment rounds, like $50 million, $100 million. So there's quite a lot of companies investing into this field, quite a lot of money and resources. So I believe it won't be that scary, but yeah, it may take time. So for big enterprises, I'm pretty sure the switch from the old-fashioned DevOps SRE ways of working to API first and AI native platform engineering may take even years, if not more.
Yeah, it's I feel like it's easy for technologists in general to just sort of fall into their comfort zone, right? And take their skills that they know and that they're comfortable with into the next role. And suddenly, like you said, you might end up 5, 7, 9 years down the track and you're still kind of doing the same things that you were. And I think it's just an acceptance that we all need to have in technology, is that we need to try and learn and adapt as we go on and be open to new ways of doing things, and this is a great example of it. In there, you mentioned around. I'd like to unpack some of your experience with maybe Terraform, because your Terraform, Open Tofu doesn't matter too much, because I think a lot of folks will have Terraform in their platform, in one way or another, and it sounds like that you've had some experience probably with some pretty gnarly setups of Terraform and, a lot of different modules maybe that you've worked with in customers, and it can get pretty complex. So can you unpack a little bit for us as to what some of the problems you've seen with that space and how those might get resolved with adopting some of these newer patterns that you're mentioning?
I believe I was one of the very first Terraform users out there. With my teams, we've created more or less 20 Terraform providers
Okay.
by ourselves, custom providers, So at very early beginnings of Terraform, I was very fascinated with the tool, with the framework. I think it was the best way to automate infrastructure by the time. In Amazon or AWS or Azure, there were not so many resources by the time, 10, 20, 30 resources like, EC2 instances, S3 buckets, maybe RDS, right? Today, they offer few hundred resources, and the number of APIs is increasing like crazy. All these new fancy AI services are popping up, from day to day, right? It's even hard to follow it, right? So that's also one of the reasons why the old way of automating infrastructures is not going to work anymore, because the number of services grows too fast. And what is even worse than this, the old services that we already have deployed into our infrastructures are changing. The APIs are changing, right? There are new Kubernetes versions every 6 months, right? New Docker runtimes, new Java libraries, new Python libraries. So it's all changing faster and faster. AI is also accelerating the process a lot, right? So what we know from the past is going to change a lot, and I believe that the old ways of building providers, writing Terraform HCL or OpenTofu HCL code is going to be just too slow. So even if you want to stay with these tools, it will be very hard to be up to date or to keep up to date your infrastructure with all the latest changes out there. So yeah, I was a very big fan of Terraform for 2 or 3 years, until I learned about the Apache Mesos project, which was the very first distributed system allowing to manage infrastructure. In its early days, it was mostly JVM oriented, if I remember correctly. So there was not even Docker. In the early beginnings of Apache Mesos, the target workloads were JVM related. But the idea behind was to build a distributed system, autonomous distributed system, managing infrastructure on your behalf, right? So you don't need to spend too much time on watching the logs, monitoring, troubleshooting. It's all fully automated in Apache Mesos. So Apache Mesos was one of the first implementations of a such system. There was another one called Service Catalog, Service Broker pattern. I believe this one was from Cloudflare, and then developed by Red Hat for a couple of years. Yeah, what is most important about these two frameworks is that they were based on the distributed architecture pattern and PID controller pattern, which is about, in very, very short, having a kind of control loop, reconciling the state of the target infrastructure, of the target resources, workloads, whatever it is, containers, JVM, virtual machines. We don't really care what is the target resource. But what is most important in these two frameworks, Apache Mesos and Service Catalog, Service Broker pattern, was the reconciliation loop running in the background, right? And then when I saw Kubernetes release 1.0, I knew, this is the best implementation so far, much better than Apache Mesos, much better than Service Catalog and Service Broker. 100% Golang oriented for a reason. There were lots of problems related to the way Apache Mesos was developed, and also Service Catalog and Service Broker trying to introduce some sort of. There were basically two problems with these older frameworks. With Apache Mesos, C++, very hard to troubleshoot and fix issues, very hard to contribute. For the community, there's lots of people, doing Java, C#, .NET, Python, Ruby, high-level programming languages, right?
Yeah.
Well, C++ is not that easy, right? So it wasn't that easy for the community to contribute, build, the tools around the ecosystem and so on. In case of the Service Catalog and Service Broker, the problem was slightly different. They wanted people to contribute in the programming language that they like. So it was okay to build brokers in Java, in Python, in Go, whatever you want, right? So in theory, it sounds really great. It's much better than Apache Mesos, because in Apache Mesos you are somehow forced to use C++, which is not always the preferred way of doing code, right? In Service Catalog, Service Broker pattern, you can use whatever you want. But so in the beginning, everyone was really excited about the idea. I was also, supporting this. But after a couple of years, we realized it's just a mess. Every broker using different logging style, different metrics, format. One broker using XML, another broker using YAML, another broker using TOM configuration format. Right? So it was like a spaghetti of different tools, different technologies, and it was really complicated. So when Kubernetes was released, I knew, okay, this is the way to go. Golang, very simple programming language that everyone can understand, right? And etcd replacing Zookeeper. Zookeeper wasn't that great when it comes to distributed system. That we know from Apache Kafka, Apache Mesos, and also Service Broker, Service Catalog framework. etcd was just better in many cases. It was easier to upgrade clusters with etcd. It was more stable, according to my experience. So that was another game changer, and the whole architecture behind Kubernetes was much better than in the other frameworks. So after Kubernetes was released, I knew, okay, this is the way to manage infrastructures. And what was also perhaps most important about Kubernetes was that it was API first oriented. So in Kubernetes, the very early version of Kubernetes was just an API server. If you listen to Kelsey Hightower, Tim Hawkins, Joe Beda, all of these guys, all the creators of Kubernetes, they like to repeat it, again and again. Kubernetes at its early version was just API server, acting as a kind of API layer in front of your infrastructure. And this is the concept which I think was the best way to go. And this is where I started thinking of migrating from Terraform to Kubernetes. Later on, Kubernetes operators, allowing me to manage more and more resources inside Kubernetes, but also outside the Kubernetes ecosystem.
Yeah.
So that's more or less the historical context, right? So we would need to spend days discussing all of it. I don't want to go into the older days like Ansible, Chef Puppet, and this kind of tools. But Terraform was the best framework, the best pattern available on the market for 2, maybe 3-4 years in a row. But since Kubernetes was released, and the Kubernetes operator pattern, which was initially introduced by CoreOS, if I remember correctly, 2017 or 16, this is where we should start thinking of more using or following the API first infrastructure more than command line tools like Terraform or OpenTofu today.
Yeah, yep. I've definitely been in the experience of trying to do something with Terraform on a new service, and the provider just hasn't been updated to support that new service, right? But I'm like, the APIs are there, I can see it, I can manage it if and then you try and look at, okay, can I drive APIs with Terraform? And then it just starts to get a bit messy from there. So I can definitely resonate with what you've said. And I think you said something really crucial there as well, which was about that reconciliation loop. And for anyone that's worked with Kubernetes, they're probably aware of that, which has been then sort of further popularized by GitOps, and that's sort of what that is all around, is having that continuous reconciliation loop. But if you look back at things like Terraform, I think a lot of folks will still be running that on like an on-demand service, or when someone wants to make a change, it will then apply the Terraform. So it could be days, weeks, or even months, between a run of Terraform for a specific component of infrastructure, right? In which time that might have changed for one reason or another.
Yeah, this is one of the pain points when using Terraform, which is actually quite a common anti-pattern of using it. But there are still many teams, trying to implement the reconciliation loop in a kind of simulated way, like Jenkins jobs, for example, right, or GitHub Actions. So they trigger Terraform every 5 minutes, every 10 minutes, just to ensure that the plan is, exactly what they expect to be deployed on the infrastructure side, right? So the plan is in sync, and there are no any drifts in there, right? So they trigger the Terraform every 10 minutes, which is for any developer sounds a little bit crazy, because every plan, every Terraform execution needs to hit all the APIs on the target cloud. So if you assume that you have 200 resources managed by your Terraform DSL script, that means that every 10 minutes, every 5 minutes, depending on how often you trigger the whole Terraform plan, you need to hit the target APIs 200 times at least to learn about the present state of the target cloud resources, right? Are they running? What is the configuration? Is there anything changed or not? So to detect the drifts, you need to hit the target cloud API very, very often. So yeah, what the Terraform community tries to do, they just re-implement Kubernetes in a form of external Jenkins jobs or GitHub Actions. So the architecture is the same. They have the reconciliation loop in place. I mean, the better teams, the teams like you said, which don't have this functionality in place. I don't even want to think of how many drifts they may find when they trigger the plan the next time, right? In case of the security breach or some other urgent update, they may be surprised by a lot of drifts they were not expecting before, right? But for the teams implementing Jenkins jobs or some other cron jobs, triggering the Terraform plan and then Terraform apply, they basically re-implement Kubernetes controller pattern in a kind of glue-ish way outside of the Terraform, right? So they simulate the existence of the reconciliation loop, which is given for free in Kubernetes. So for me, this is one of the biggest anti-patterns in the industry today. In Kubernetes, we have this feature, given for free. It's actually, this is what Kubernetes is: a set of controllers, a set of operators, triggering the reconciliation loop every 30 seconds, every minute, every 5 minutes, depending on your requirements. So this is what is given by Kubernetes for free, but we try to delegate this functionality to some other CI/CD systems. In most cases, CI/CD systems. In the early days of Terraform, it was also cron job. In many places. So this is something I can understand today. So in many discussions with the Terraform community, they say Kubernetes is too complicated. You need to learn about controllers. You need to learn about operators. But what they do, in fact, is actually the same architecture, right? They're re-implementing Kubernetes with use of the CI/CD jobs. What is even worse than this is that Jenkins is still the most popular CI/CD on the market, 40% of the market, if I remember correctly, according to all the surveys from 2025. That means that most of the Terraform runs from inside Jenkins, which is not that easy to manage. As we know, the plugin spaghetti, XML still being used there, Groovy scripts, So Jenkins itself is another problem, but running Terraform from inside Jenkins is for me, it's 10 times more complicated than Kubernetes itself, right? And what is worth mentioning there is that the whole community behind Kubernetes tries to make Kubernetes boring. So they because you may still find people, saying, you need to learn Helm in Kubernetes. I don't know what is ingress. I don't know how to scale Kubernetes. I don't know what is etcd, reconciliation loop. So in the beginning, it may look a little bit scary, but what the whole community behind Kubernetes is trying to achieve is to make Kubernetes boring. This is the goal for the next years for the Kubernetes community, to make it extremely boring. So we don't even need to think of it, right? And I believe this is also one of the reasons why more and more people are going to switch from Terraform and OpenTofu to Kubernetes, acting as a kind of core of their autonomous systems, autonomous platforms.
There's definitely a lot of tools that I've seen that aim to, like you said, make Kubernetes boring, and they do a really good job of it. And that space is only going to get better, I think. I think as the years go on, the more abstract most folks can get from the underlying Kubernetes and not need to worry about necessarily the nuts and bolts. I think there'll still need to be that expertise, but I think that kind of shifts down maybe onto the vendors and the partners who are making tools, and then the general IT community can then sit above that layer. Hopefully is where we sort of get to with that. And for folks out there who maybe are listening to this conversation and thinking, oh, I'm still sort of doing things, in a platform team, in maybe, the older style way, if you like, or the things that they're comfortable with. Are there some frameworks, or what resources would you point someone to who wanted to learn, more about some of the frameworks around the more autonomous and API first driven? I think I've seen the work from CNOE, and I know that you've mentioned, is it ApeiroRA as well? One of the frameworks that we've got, and I know that you've got a lot of experience around this area, so I think that could be cool to unpack a little bit.
Yeah. So for me, 2025 was a year of the mindset shift for lots of hyperscalers, lots of vendors, defining building the technology, defining the reference architectures. And like you said, CNOE, which is a kind of reference architecture developed by Amazon and Cisco for building proper platform engineering environments, or introducing proper platform engineering practice, which is 100% Kubernetes operators oriented, with some sort of support for Terraform. So Terraform is still there. If your team is using Terraform today, it's not that hard actually to switch from Terraform to CNOE, the framework provided by Cisco and Amazon, right? Of course, it's more like a kind of open source reference architecture. Everyone is allowed to contribute and use, but it's not officially supported by any of these companies, according to what I know today. Another one is AKS Labs from Microsoft. Again, Microsoft recommending Azure Service Operator, ISO project to manage Azure infrastructure, not Terraform, not OpenTofu. They are very explicit about using their own operators for managing Azure cloud resources. Another reference architecture which you can find, I believe we will put all the links under the recording on YouTube, so it will be there. So Microsoft officially recommending operators for provisioning and managing the infrastructure. There is another one from Google, which I would mix with CRO, the latest abstraction or templating framework from Google, KCC, Kubernetes controllers for, Kubernetes config connector, with CRO, which is another engine, but built by the same team, I believe, allowing to abstract the resources. So you don't need to define 200 different resources to deploy a simple application. You can define only a very high level definition of the application, like for example WordPress, which in Terraform, in a typical Terraform, requires you to define S3 bucket, database, RDS, some 2 or 3 pods for the PHP WordPress application, some ingress controller, maybe some firewall, some backups, monitoring, blah blah, observability, logging, and so on. So there may be quite a lot of components being involved into a typical WordPress deployment. With use of CRO, you'll be able to define the whole WordPress stack with minimum 2 lines of code. And I already saw a couple of examples like this, deploying a WordPress infrastructure with the whole networking, like VPC, peering, ingress controllers, gateways, databases, with only 2 lines of code. So this is quite, I believe, the best way today to abstract our infrastructure even higher than Kubernetes basic components. So in Google you have KCC, then you have the other even wider reference architectures from SAP, ApeiroRA, that you mentioned before, right? Which is kind of European Union effort led by SAP to build a reference architecture for building clouds. So you can build your own clouds, Mat Cloud or Piotr Cloud or Octopus Deploy Cloud, right? So which is 100% built on top of Kubernetes operator pattern. Again, Kubernetes is like a heart, it's like the operating system of the architecture. Everything is built on top of operators. But this is not important there. What is important there is everything is API first oriented. So all these different components, different systems, subsystems, different layers can talk to each other through REST APIs, right? So if you need a new VPC or a new VLAN, it's always just a matter of HTTP REST request, nothing else, right? It's very easy to trigger some operations and integrate subsystems. So ApeiroRA reference architecture, so I think these are the most popular ones. So CNOE, the one from Cisco and Amazon, ApeiroRA, the one from European Union and SAP, are the biggest and the most complicated, I would say, the most detailed. What is also worth to mention, the ApeiroRA reference architecture was also used by SAP to build their own cloud in Frankfurt. Okay. So I'm not sure if you are aware of it, but since about 2 months, SAP offers their products, their services, their business catalog, service catalog to be deployed not only in Amazon or Google or Azure like it was before, but also in their own cloud. So you can choose. You have a choice today. You can deploy to SAP native cloud in Frankfurt, and they are currently working on another region in China for obvious reasons. So Apiro is something you can use not only for your platform engineering team or for your department or for 1 or 2, 3, 7 products. This is an architecture you can use to build your own cloud, which is very, very powerful. With CNOE, it's not like that. CNOE is very limited to the product level, I would say, right? So to deploy particular product to be managed by particular team, not like a global cloud, global framework that is supposed to be used by external customers all over the world and so on. So they are slightly different. But what is good about them is all of them are built more in a kind of Lego way. So you can choose, you can cherry pick the blocks you need in your organization, right? So if you are not interested in bare metal in the Apiro reference architecture, you don't need to use them, right? If you don't like Gardener for provisioning Kubernetes clusters in the Apiro reference architecture, you can choose another framework, Cluster API, which is perhaps much more popular today in many places than the Gardener, right? So we have a lot of freedom to replace particular blocks, to choose what works for you. But what is common for all of them, API first. No one is using binary tools or tools not having any kind of APIs or any kind of interfaces. All of them are API first, and all of them are managed by Kubernetes, which means they have a kind of reconciliation loop in place. And in 2025, most of these architectures were published. Before that, it was really hard to convince enterprises. It was really hard to convince the old-fashioned Terraform SRE teams to make the switch from Terraform to operators. Now it's easier. We have 5 or 6 really big, really advanced reference architectures being supported by the biggest companies in the world today.
Yeah, awesome. Like you said, I'll put all the links below. It's interesting to hear those common foundations between all of them, though. But one of the cool things, like you said, is that you can base it on the requirements of your organization, right? You're going to have different requirements for who you're trying to serve internally. Are you trying to work this platform for external customers? Everyone's going to be a little bit different there. So I think, the power of these frameworks is to be able to look at them, see what the common denominators are, and then pick the pieces that are going to work best for you and your organization. If I bring it back to some of your experience around kind of figuring out when you're like, what was one of the things that was the light bulb moment for you, maybe when you were managing or helping customers with their Terraform, and then now recommending that they maybe look at these reference architectures? There's probably no particular one point in time, but if you were to work with a customer today, what are some of the things that you might be red signals for you when you're working with them and looking at their environment to then suggest that they go across and start looking at these new models? And where would you suggest they start? Is it with those reference architectures that we spoke about? Is that the starting point for learning maybe this newer modern way of managing infrastructure?
Yeah, so today I think that the best starting point is to look into one of these reference architectures, depending on your personal preference. If you like Cisco and Amazon more than Microsoft, you can look into their reference architecture. So you have plenty of choices. 5 or 6 biggest enterprises that they have their own recommendation for building Kubernetes centric platforms today, right? So yeah, it's up to you. In Europe, most of my colleagues today, they look more into this SAP Apiro framework, not only because it has the broadest scope, starting from hardware to enterprise networking, but also because of some sovereign requirements which pop up over the last couple of years, right? So, but it depends on your own preference. When it comes to the starting point, I think it's kind of typical to any change in IT that we know from the past, right? So you usually start with some sort of POC environment, MVP environment. You build something very simple, something very small to start with. After a couple of experiments, after a couple of tests, you may think of migrating some non-business critical workloads on top of the new infrastructure. The good thing about operators, most of the Kubernetes operators, is that most of them support some sort of adoption methods, allowing you to import or adopt resources being created or provisioned by Terraform and not before, right? So in many cases, you can make the transition in kind of fully transparent way. You don't even need to recreate the resources, the cloud resources. You can just import them from Terraform to the operator control plane in a fully automated way. Yeah, this is possible, and this is very important to consider, because in case of stateful workloads like databases or systems that need to run 24/7 with Kafka and this kind of components involved, it is really hard to recreate them completely from scratch, right? Master to master application Kafka is not easy to set up. It takes time. Testing is hard. So it's always best to import what is possible to be imported from Terraform to operators. Most of the operators support the read-only mode. That's also worth to mention. So it's not like it's a hard switch from Terraform to operators. You can use both systems in parallel for some time, like a couple of weeks, maybe a couple of months, just to ensure, okay, we know how it works, right? We can see all the resources created in Terraform in Kubernetes operators control plane. Everything works correctly. This is what we expect, right? After you achieve some level of confidence, this is the way to go. Everything works fine. You can switch the operators from the read-only mode to read-write mode, and then disable Terraform completely, right? So there is a couple of patterns: lift and shift, of course, and so on. Full destroy, recreate migration is also possible in many cases, but of course, for only for apps which don't need to run 24/7. Greenfield projects is also a very good way to start with the new way of building platforms. So all the new greenfield projects should already start with the new inside the new infrastructure under the new control plane, not the old one, right? So yeah, that's how you need to start. But today, I think it's really easy when comparing to what was there 2, 3, 4 years ago. No reference architectures at all. Not so many people knowing operators, how it works. Not so many documentation out there, right? Today there is tons of documentations. There are many conferences, meetups discussing this kind of topics. There is the new organization created by Linux Foundation called Neonifos. I'm not sure if you've heard about that before. We can also put the link under the video. Neonifos is like the new CNCF for Europe, and which was created for some political reasons. But what is most important to me is that this new Neonifos organization is 100% API first oriented, right? So there are no any tools or frameworks yet, and I hope it's not going to change, which are not offering, API, any kind of, interfaces to allowing for easier and better automation. So all the projects under Neonifos are 100% Kubernetes centric, 100% API first, and there's lots of meetups, conferences. There's lots of enterprises in there. I was seeing Siemens in the conferences and meetups. I was seeing Deutsche Bahn, the biggest rail network in Europe, I suppose. I was seeing people from Allianz. I was seeing people from a couple of financial institutions, the biggest European financial institutions. So there's lots of organizations you can learn from. The community is very, very supportive as well. It's relatively easy to reach out, through Slack, through community meetings, for all of these, community initiatives to the people having already some experience in the area, who did already, 2, 3, 4, 7 migrations from the old-fashioned Terraform to Kubernetes-based platforms. Yeah, but and of course you need to be ready. It's a journey, right? In the end, it's a kind of journey. It's going to be a process. But what is good about it, or what it makes it much simpler than a typical migration in IT, is that if the new platform is better than what developers, what people know from Terraform and OpenTOF environments, if the new platform is better, then there is a line of projects willing to be onboarded on top of the new infrastructure. You don't need to push them. You don't need to ask them. You don't need to escalate. You need to migrate from this environment to that, because it's our new policy, it's our new strategy, it's our new architecture. You are forced to do so, right? In this case, according to my experience, it's the opposite. The project teams, the products, the applications, the business owners, they want to be onboarded on top of the new infrastructure faster, or as soon as possible, because they see the value behind, right? They see the value behind. There is less problems. The infrastructure is more automated. This is an autonomous system which doesn't require too much effort to be managed, right? In opposite to the old-fashioned infrastructure, it's much easier to run experiments. It's much faster to integrate new APIs. Like you said, if you see a new API being published by XYZ, it's much easier to integrate in these environments, right? And the speed of delivery today, is becoming a critical feature in many areas. It makes the migration much simpler. So if you convince the development teams, the product teams, this is better, faster, more AI driven, it will allow you to deploy in a matter of minutes or hours. It will offer you automated upgrades of your Java libs, of your Docker containers, whatever you use. So you don't need to bother anymore about this kind of basic elements of your infrastructure. Then it's much easier. And this is always my hope. when I have a chance to build a new platform like this, my biggest hope is to convince the organization, as many teams as possible, this is the best way for them, and so the push comes from their side, not from the platform engineering or from the infrastructure team side, right?
Yep, and that's the thing, right? Like I don't think I've ever met a product manager or a team of developers that are happy to hear the infrastructure guys come and say, "Oh, we need to now move your application or whatever." That's unplanned work for them. They don't really care. So if you can sell them on the value of instead of getting into the nuts and bolts of the infrastructure, but sell them on the value, like you said, of what's important to them, they will want to be on the new platform, and they will go there by default. That's the hope anyway, right? So
exactly. So when it comes to platform engineering in general, again, in my eyes, it should be about the APIs we discussed before, but another very important element in there is the portal, the web interface, allowing all the developers, all the users for easy, access to the infrastructure, right? Which also enables, the development teams, the product teams, like you said, to do whatever they want through the portal. So without any, GitOps pipelines, YAML or HCL, whatever it is, without any kind of, technical, without touching any technical layer to deploy or to see what they want to see. Through the portal, a similar way to how we use Azure Portal or AWS Console today, right? If you give to the development teams something like this, a beautiful portal, having access to all the infrastructure components, allowing them to deploy whatever they want, offering a kind of service catalog with all the components available in this particular organization, they will love it. I'm pretty sure about that, and the push will come from their side. They will be fighting between each other. They will be escalating between each other. Which project should be the next one actually being onboarded on top of the new platform, assuming the platform is implemented properly.
Yeah.
Because this is another problem, of course, because the Kubernetes-centric architectures are not easy to build. That's also why we need all these reference architectures. I don't remind any reference architecture for Terraform created by Amazon or Cisco, right? There is a couple of boilerplate templates on GitHub published by different organizations, but I don't remind any kind of high-level reference architecture for the entire enterprise organization. Because in case of Terraform and OpenTofu, it's slightly smaller scope, and it's a little bit easier to start. With distributed systems, it's a little bit more complicated, and you need a bigger picture to do it correctly. So the decision about building the proper API first infrastructure is the first step. The second step is to do it properly, to build the portal properly, which is very rare today. If you talk to many enterprises and see what kind of portals they currently have in place, it's not always that great, right?
That's a great takeaway. And I want to just finish up on something that you mentioned, which was around the community aspect of this. And, that's, I think a lot of it is driven just on the nature of a lot of these things, like the frameworks and the tooling being open source and then sort of bleeding into the community. But like you said, the community is such a powerful aspect, both for people who are trying to learn and network and share information with others, right? Whether it's conferences, user groups, and discussions like this one right here. So you're obviously, given that you're here talking to me, I know that you're happy to network with folks and give back, and I know you do user group and conference talks as well. So how important has that been in your career? And for folks who might not have taken the step yet to get involved in those communities, what would you say to those folks?
Yeah, this is actually a very, very interesting question because it changes over the time. I remember in my very early days, configuration management camp in Ghent, in Belgium, in Europe, was the most important event for me. This is also where the DevOps was introduced in this particular event. After that, it was mostly about the DevOps Days community, DevOps meetups, DevOps Days conferences all over the world. I remember there were also a couple of events like this in Sydney, in Australia. They are basically all over the world. I think there is like 60 or 70 instances each year today. So the DevOps community was the best community for me for 5 or 7 years in a row. After that, I switched into MazesCon and KubeCon, which is the biggest conference today. Huge source of information, and the number of collocated events today in KubeCon is insane. It's like 20 or 30 collocated events just 1 or 2 days before the actual KubeCon. It's just too big to me. But still, there's lots of vendors, lots of great people you can meet there. So all the KCDs, the old Kubernetes community days, another way to learn about operators and the Kubernetes ecosystem. But the latest finding for me is the very small conference in Europe. Maybe not that small. I think there is close to 1,000 people visiting the conference each year. Is the container days, container days in Hamburg, and container days in London, which is like 100% focus on Kubernetes operators. And you can find a lot of Kubernetes operators developers from Red Hat, from NVIDIA, from SAP, all the leading companies out there. You can talk to them. You can go for a beer with them in the after party, right? It's very easy to reach out to people. which are unavailable to you in KubeCon, because in KubeCon you have like 20, 30,000 people, and it's really hard to even find them, right?
Mm-hmm.
Or to learn who is who, right? So
Yep.
I think that Container Days is small enough to talk to. Kelsey Hightower is a very good example. I'm going to visit the next Container Days conference in London next week, actually.
Mm-hmm.
Kelsey Hightower is going to be there, and you can talk to him. In KubeCon, it's not that easy. So for me, it's today it's the most vibrant community when it comes to platform engineering, right? Because these guys, there's lots of guys doing R&D, not only adapting the technologies or using the technologies which already exist, but there's also lots of people building the operators and operator ecosystem.
Yep.
So for me, this one is the most important today. But of course, everything related to CNCF and collocated events like Platform Engineering Day,
Mm-hmm.
which is also part of KubeCon today. There's lots of typical CNCF environments where you can contribute or learn anything you need to adapt the new ways of platform engineering.
There's a lot of things that I want to talk to you about, but we're running out of time. So I'm going to have to get you back because I've taken some notes even as we've been talking about things that I want to unpack with you further. I know you've got a lot of experience and knowledge, but I want to sort of end this with a question to you. And we've covered a lot of different things. We've covered APIs and platforms, infrastructure, orchestration. And if there's one key takeaway from folks from this conversation, what would that be from you to them?
I think there is, when it comes to the technical layer, I think over the next couple of years, we need to focus on two items. API first, which is not only about REST APIs or Kubernetes APIs. It can be anything. It can be gRPC. It can be RPC, remote procedural code. I don't care what kind of interface it is, but some sort of interfaces, APIs, and AI agents being capable to talk to these APIs. Right. I think this is the future for the next couple of years at least. For our field, infrastructure, platform engineering, DevOps, SRE, to integrate these two worlds together, right? So the agents are capable to consume, to integrate with the interfaces exposed by our systems. So that would be my focus, and this is actually my focus today, to build all infrastructure exactly this way, right? So everything is API oriented. And there's lots of agents being capable to talk to this infrastructure.
I love it. And that's also a note to myself. If I can get some more of your time later in the year, I think we will have a specific episode about sort of agentic AI in platform engineering. I think that's a topic we could dedicate an entire episode to. So if folks want to reach out and connect with you, I assume being the sort of community networking person that you are, you're happy to do that. Where's the best place for folks to reach you online? And of course, I'll put the links below as well.
So for me, I think it would be LinkedIn. I'm publishing quite a lot of stuff in there, maybe even too much.
Mm-hmm.
Sometimes more than 2 or 3 posts a day. So LinkedIn would be the best way to follow me. And every week, every month, I'm trying to share all the links to all the latest findings, like the latest architectures, latest frameworks. All the innovation happening around the modern AI native platform engineering. So
Yep,
LinkedIn,
fantastic. Yeah, I
best way
love it.
to go.
Yeah, I'll put all those links below. I'll put the links to everything that we've spoken about in the show below for folks as well. And with that, thanks so much for your time today. This has been a great conversation. There's lots of different resources here for folks to go and check out to see maybe where things have gone over the last 12 months and where they're going in the next few years. So I love the insights you've given us today, and thanks so much for your time. I've really enjoyed this conversation.
Thank you for having me.